Limit is x goes to 1 of tan squared of x minus 1 divided by x squared minus 2x plus 1. The first thing we're going to do is try plugging a 1 in for each of the x's. That will give us the tangent of 1 minus 1 and then quantity squared. Remember that tan squared means to work out the tangent and then square the result. Divided by 1 squared minus 2 times 1 plus 1. We have the tangent of 1 minus 1, which is 0. Quantity squared divided by 1 squared, which is 1, minus 2 times 1, which is minus 2, then plus 1. The tangent of 0 equals the sine of 0, which is 0, divided by the cosine of 0, which is 1. 0 over 1 is a 0, so we have a 0 squared, divided by 1 minus 2 is a negative 1, plus 1. 0 squared is 0, minus 1 plus 1 is 0. We have the 0 over 0 indeterminate form resulting from trig functions with power functions, which means we can make use of the identity limit as theta goes to 0 of the sine of theta divided by theta equals to 1. In order to make use of that identity, we have to rewrite any non-sine and cosine functions into sines and cosines. And that means we will need to rewrite the tan squared of x minus 1 into sine of x minus 1 divided by cosine of x minus 1, and then its quantity squared. All of that over the denominator of x squared minus 2x plus 1. Since we have a fraction in the numerator, we're going to need to take the fraction in the denominator, reciprocate, and multiply it. It's not a fraction right now, but I'm going to make it a fraction by putting it over 1. Our next step will be reciprocating and multiplying. So we have the sine of x minus 1 divided by the cosine of x minus 1, and then that entire thing squared times the reciprocal, which is 1 over x squared minus 2x plus 1. And now we can multiply the numerators and denominators. The numerators, we have sine squared of x minus 1 times the 1, so sine squared of x minus 1, divided by, and in the denominator we have the power function x squared minus 2x plus 1. I'm going to write that first, times the cosine squared of x minus 1. Now we still are 0 over 0. We haven't changed that just yet, and that's what our next step is going to be. To change that, we have to make use of the identity, and to make use of the identity, we have to isolate our sine functions. So our next step is to isolate the sine functions. We have a sine squared of x minus 1. Now I'm going to write it as sine of x minus 1. It's in the numerator, and then I'm going to do quantity squared. That just makes it easier for phase matching it. And what I have left, I can write into its own fraction, and what we have left is x squared minus 2x plus 1 in the denominator, and cosine squared of x minus 1 also in the denominator. Now we will phase match. We have the sine of x minus 1 in the numerator, phase of x minus 1. We need to put an x minus 1 in the denominator to phase match it. Notice that x minus 1 is being squared because of the quantity squared, and therefore to compensate we're going to put an x minus 1 in the numerator of the other fraction, but make sure it's squared so that they would cancel each other out. At this point we've created the identity for the first fraction. The second fraction, however, is 0 over 0 because we have power functions and both of those are making zeros. And we're going to need to therefore work with those power functions, which the method for those is the factor and cancel method. So we're going to have the sine of x minus 1 over x minus 1 quantity squared. We'll leave that alone. And the numerator of the other fraction we're going to leave alone because it's technically already factored. And now we're going to factor the denominator, trinomial quadratic. We need two numbers that multiply to be a positive 1 and add to be a negative 2. I believe minus 1 and minus 1 will take care of that. And then we also have this cosine squared of x minus 1. Now if you look, there's an x minus 1 in the numerator. There's actually two of them, and there's 2 in the denominator. and they can cancel out with both of those in the numerator, leaving us a 1 in the numerator. At this point, we've eliminated the 0 over 0 from that second fraction, and then the first fraction, which is 0 over 0 right now, is the identity. And that means we should be able to work out this limit at this point. I'm just going to rewrite exactly what I have before I work out the overall limit. And I have a 1 left in the numerator of the other fraction, and it's over cosine squared of x minus 1. Okay, according to the identity, that first fraction is phase match, and it has a limit which will equal to 1. So that's just going to be a 1 squared. And then the remaining expressions, I can just plug a 1 in for the x's. So I will have 1 over cosine of 1 minus 1. And then remember, you evaluate the cosine first and then square it when you have cos squared. Now 1 squared is a 1, so we have 1 times 1 divided by 1 minus 1 is a 0, so we have the cosine of 0 and then quantity squared. So we have 1 times 1 divided by cosine of 0 is a 1, 1 squared. 1 squared is 1. 1 times 1 over 1 is going to come out to 1.